Hello, it's Paul Duvall. I'm a founder of Stelligent and CTO of Emphasis Stelligent. I've been talking about continuous compliance on AWS using config rules recently. I also have a blog post, so I thought I'd go over the slides and show a screencast of this. And before I get into it, I just want to talk about kind of what led me to all this continuous stuff. So my very first project in my career, I was working for a large systems integrator. And I started off as a software engineer. I was building these large custom systems for enterprises, for these large organizations. And even those days, I was always interested in, and I would participate in building the end-to-end systems, from security to app development, building deployment, databases, messaging, installations, really everything. Probably something you would refer to as a full-stack developer these days, but it definitely wasn't a thing, 20 years ago. So one of the key lessons I learned on this project is what motivates us. To me, that's releasing and then receiving the software. The releasing software motivates the creators, and the receiving software, the creators being the engineers and the receivers being the end users. So that everything comes down to releasing software. And so on this first project, it was like 2 years before the software actually got released. And I actually got to install it at this medical logistics center. And that's when I immediately knew that's what motivated my work. And I think if you ask people that are developing and delivering software systems and then talk to end users, you're going to get close to universal agreement on this. Yet we waited 2 years to release the software system. So the primary reason for this delay was the system complexity. So I had over 100 people that were working on, it was a number of different subsystems, and it was definitely what you would consider a monolith these days. The software had to be manually installed, and so it ultimately got batched and got delayed, and I found it pretty frustrating, that it just took a few days just to get the application portion, not the environment of the databases of the software system built and deployed within a simple shared integration environment. And so it was on this project that I saw a single page industry magazine advertisement, kind of like this, where it had a keyboard button, and it just had the one keyboard button and it had the word integrate on it. And to me, what it symbolized at the time was it symbolized the means to the end. The more that we could integrate the complete software system from recent changes, the better chance we could, on a regular basis, release software to users while having a collective motivation between the software users and the software engineers, the software creators. And that's ultimately what motivates me every day in creating these kind of continuous systems for our customers. With continuous delivery, you're integrating the entire software system, the application code, the configuration, the infrastructure, and data with every code commit. And ultimately, this accelerates the speed and the confidence in delivering software to production. You're getting that feedback all along the way. And so this is why I've always been interested in turning these things up, right, into a continuous mode. And so that's what I'll be going on, is really how to apply this continuous mindset to security and compliance. And you treat compliance as a code asset that can be version tested and run with every change, the same as application code. And so in helping our customers accelerate the speed, they're going to get that quicker, more useful feedback. In particular with security and compliance, they're going to get that confidence, though, as I mentioned. So what does a typical security and compliance scenario look like? If you think about how that goes today, this is a scenario that I typically see. It's something like, let's say internal compliance is, they're conducting an audit in 3 weeks, and we need to make sure that we're compliant with all of our internal policies, let's say, right? And so what often ensues is this heroic effort of people, discovering or creating documents and other artifacts indicating what the policies are, along with checklists that stipulate that they've indeed been executed against the software system, or issue tracking system and traceability and things like that. This might include signed approvals from change advisory boards, things like that. And if the scope is at the enterprise level, where it's a significant internal audit, people might be spending late nights and weekends just to prepare themselves for the audit. You might run through mock Q&As. And so if the audit didn't go so well, regardless, your team might receive some report, but if it didn't go so well, and definitely viewing through a cynical lens, people ultimately they try to determine who was most at fault, which human cause the errors. And so this is what I liken to what Jez Humble refers to as risk management theater, where all these activities associated with compliance is just a mere spectacle that has nothing to do or very little to do with assessing or reducing the actual risk. And it's very often focused on human failure versus systems failure. So meaning someone to blame without fixing the root cause of the problem. And these activities are also, they're focused, in that scenario I talked about, they're focused on a single point in time, a single event, and it doesn't consider the reality that software is a dynamic system. So what if there's a way that you could codify these policies in code and then have these policies automatically triggered and continuously based on events that are just regularly occurring? So, for example, what if there's a way to ensure that, say, all your ABS volumes and your CloudTrail logs are encrypted and your Lambda function settings are in compliance with your team or your organization standards? So with AWS Config Rules, these types of active configuration monitoring checks, and also what you can do is, since you're writing these rules in code, you can establish a deployment pipeline that applies these changes to the rules against your infrastructure, against your AWS account, using a fully automated workflow. And so with continuous compliance, you no longer conduct a separate event for which everyone works overtime, prepares weeks, and ultimately neglects to meet the true policy objectives. Instead, your team and your organization is continually compliant based on the policies that you've codified in this version-tested code that's continuously applied to your infrastructure. So one of the typical challenges in organizations around compliance. So first I've seen is that there's an inability to scale. There's an inability to adapt to the speed of change at scale. And so in the cloud, this often gets magnified. There's an inability to properly assess or have integrity or in knowing that you're evaluating the kind of constant change that's going on in the infrastructure. Even before the cloud infrastructure changes were regularly occurring that might violate an organization's policies without the knowledge of those who manage the infrastructure. But with the ability to make the changes through APIs in the cloud, these changes are essentially exponential. It makes it really difficult to assess without a systematic and automated approach. But the great thing is, because you have everything as an API, you can also use that and leverage that to be continually compliant. But I'll get into that later. So what you often see are these compliance events, like the one I talked about before. Is you have these monumental efforts where you comply with internal or maybe an external audit. It is the antithesis of a non-event, all right? And so without continuous compliance, audits and these other reviews take up a lot of time and resources. And these are manual efforts. You're repeatedly performing the same manual activities in order to achieve, quote, compliance with the organizational policies. And without continuous compliance, your organization is always non-compliant because the state of the change is constant, and the inability to assess compliance without a fully automated approach. And this leads us to in many ways, the key issue, and that is you have less effective feedback. You're ultimately you'll either release less often, or you'll still release at a quick pace, but without true compliance. And so you're reducing the product team's ability to increase or accelerate the speed of change to their end users because the compliance is either performed fully or partially manually. And usually there's a separate event, and that's you end up batching up changes because it is such a monumental activity. So what's the solution for this? And by the way, this is one particular part that I'll be going over of continuous compliance. There's actually a lot more you can do, but I'll be talking about really at the AWS account level. You can also incorporate checks into your deployment pipelines against your application code, and then compliance of things like your pipeline and so forth. And so this is kind of one view on this. And so these are some of the services, AWS services. So this is an AWS native solution. And so first is AWS Config and Config Rules, right? So AWS Config is a fully managed service for tracking AWS resource inventory and changes. So with config rules, you can ensure that existing and new AWS resources conform to your company's security policies and best practices. With CodePipeline, that's also a fully managed service for releasing software using continuous delivery. And then you can use CodePipeline to orchestrate AWS config and config rules changes to your account. This is also integrated with CodeBuild. So CodeBuild is integrated with CodePipeline. It's also a fully managed service for building, testing, and deploying code. And actually, in this context, building and deploying your config rules artifacts to your AWS account. All this is automated through AWS Cloud Formation, which is a tool for creating your AWS resources with templates. You can automate the entire AWS config solution. So not just config itself, but also all the supporting services and tools like IAM and SNS and S3 and some of the services that are integrated, Lambda, things like that. CodePipeline. And then the last service is AWS Lambda, which allows you to run. It's also fully managed. You can run your code in response to events. And so I won't be going over this in detail, but you can use Lambda to write custom config rules in your own preferred language. But I'll get into some of the high level on that later. So AWS Config, it ultimately provides a detailed view of your resources associated with your account. And it includes how those resources are configured, how they're related to one another, and then how the configurations and the relationships have changed over time. It uses the simple notification service to stream the configuration changes and notifications. It uses S3 to store the configuration items as part of a configuration stream. And then you can manage your permissions to the actual service itself through AWS Identity and Access Management, IAM. All the config API calls are logged through CloudTrail. And so in this scenario, you have configuration change that occurs in your AWS resources. Config records it, stores it into S3, and then in this case, it uses a config rule to evaluate the recorded configuration against your desired state. And then these evaluations come in the form of dashboards, SNS, API, so forth. So how do you set this up? This is an example of the console. There's lots of different ways of doing this. You can do it through the CLI, SDK, Cloud Formation. I'll show an example of that later. But just to get you an idea, this is a screenshot from the AWS Config Console. You can, with this button, you can turn it off. That implies it's on. So actually, to start things off, you would hit a button to turn it on. And then there's different types of resources you can record by default. It's set to record all resources in a particular region. It's generally speaking, it's a region-based service. But you can also optionally include global resources like AWS IAM, for example. You can have specific types of resources. You can modify the data retention period, which is by default 7 years. You can configure, or you can create a new S3 bucket to store your configuration items or your overall configuration stream. And then you can stream to a particular SNS topic. You can use CloudWatch event rules. And then you have an overall identity and access management IAM role that you can associate with your AWS config service. So when you have configured this, you can look at the AWS Config Dashboard. You can see the resources that it's tracking, and then you can see the rules that are not in compliance with your infrastructure. And so you can see here's a couple non-compliant rules and how many resources are associated with that. So the dashboard provides sort of that at-a-glance kind of view. So let's get into config rules. So a config rule represents the desired configuration settings for the specific AWS resources. You can also do it against the entire AWS account. If it violates the rule, it flags the resource. It's either non-compliant or compliant. And you can get notifications through SNS. And most notably is you can use managed config rules, which I'll go over in the next slide. You can also define your own custom config rules as well. And so with managed config rules, AWS Config provides these customizable, predefined rules that help you get started. And so at this time, there are 82 managed config rules for compute and database management tools, network, content delivery, security, identity, and compliance, and storage. And more rules are being added. So a few examples, you see some of the ones listed here, but some other examples are VPC flow logs, ensuring that VPC flow logs are enabled against your Amazon VPC, that your IAM root account does not have an access key associated with it, that your IAM users have MFA enabled, multi-factor authentication, and you can also, it's customizable, so you can say, okay, users with this particular tag, maybe on a particular team, or non-resource type users, for example, or your S3 bucket, it does not have public read, or RDS has multi-AZ enabled, things like that, and you can add your own config rule through the console. You can also do SDK Cloud Formation. I'll show an example of using Cloud Formation a bit later. But as you can tell, is basically config rules you can think of as you can define a bunch of best practices for your AWS account and for specific teams or specific resources or whatever. And then you can set it up to run periodically. You can run also based on changes to events, and so you can effectively always be continually compliant. And you can see the Config Rules dashboard, at a glance, you can see which ones you're non-compliant with. You can drill down into the resources from there. You can also write custom config rules. So in addition to those managed config rules, you can write your own custom config rules that are specific to your team, your organization, using an AWS Lambda function that you write in a high-level programming language like Node.js or Python or Go. And so definitely consider using the rule development kit. It's called the RDK when you're developing your own config rules. The RDK, what that does is it creates and then it deploys your config, your AWS Lambda, your IAM resources as an atomic unit, so all together. You can see just a sort of a snippet of some code here. This is in Python, and it's just looking to see if the current date is less than the expiration date associated with an AMI. Whether it's compliant or non-compliant based on your specific rules. And so managed config rules uses the same approach, but the difference is it's effectively, it's locked down. You can provide parameters to it, so you can customize it in that way. But if you want to write your own config rules, for your own organizational policies, it provides that capability. And like I said, using the RDK makes that kind of simple to deploy. So AWS CodePipeline is that fully managed service. It orchestrates a release workflow for continuous integration, continuous delivery, and continuous deployment. And with CodePipeline, you can define a series of stages that are composed of actions. These actions perform tasks in a release process from the code commit all the way to production. And CodePipeline provides part of that continuous capability that makes up continuous compliance. What you see here is a 3-stage pipeline that deploys config rules to a region within an AWS account. So you have a source, build, and deploy stage. And you can see that there are actions. So this is source action, artifact, deploy config rules, and deploy CloudTrail actions. Everything within action has to be successful before it transitions to the next stage. And there are a number of different provider or action types. There's source action, build, test, deploy, invoke, and approval actions that you can use. And then there are different providers that you can use. So for example, with source, you can use GitHub and S3, code commit and ECR. With build, you can use code build. You can also write your own custom actions as well. And then with the deploy, there's a lot of different providers as well that you can use, including Cloud Formation, ECS. You get into things like Elastic, Beanstalk, and Opsworks, so forth. But in this context, what we're doing is we're using CodePipeline as our release workflow to deploy those config rules. So we could ostensibly run static analysis against those, the actual code associated with those, if we wanted to as well. And we can also run tests and things like that. So it's a part of the. So we're treating it the same way we would treat application code. So AWS Cloud Formation, this provides a common language for you to describe and provision, as it says. It's that single source of truth. So you use a declarative template in which you can define your resources, and there are over 100 resources that are supported, 100 AWS resources that are supported with Cloud Formation, but you're able to treat it as an atomic unit within a life cycle. So You can do it based on how frequently certain things get changed. But this is just an example, maybe of provisioning an EC2 instance. And so you're doing this without having to click through a bunch of steps and things like that. Instead, you get to define it in code. You can version it. You can run tests against it, static analysis, and so forth. You can launch it through the console. You can launch it through the CLI. But this is a common tool that we use to ensure that everything, the whole infrastructure and so forth, is fully automated. So let's look at an example. You have the configuration recorder with AWS Config. This is that button that I showed before, where you can turn on and turn off, but you can, instead of clicking the button, you can define all of this in code. So you can see it's not just, this is a snippet, it's not just the configuration recorder, it's also associated IAM permissions, the IAM role, and the SNS topic, and the S3 bucket, and the associated bucket policy too. And then this is how we define CodePipeline and associated resources in Cloud Formation. And so you can see it's not just the pipeline, but it's also some of the associated code build projects. You saw in the pipeline before, it had 3 code build actions. So these are the 3 code build projects that you can define all in code. You have the associated policies, KMS, keys, the S3 bucket, policy, and permissions. And here's a snippet from the code, from the actual code pipeline resource. You can see that source stage gets defined in code, the provider GitHub. Here's an action deploy config rules that's calling out to code build. So let's take a look at how code build gets run. And so here's the code build project, and this is a Cloud Formation resource. You can see I'm defining some of the associated attributes, including the permissions, the build compute type, basically what container we're running code build for, how we're caching data, so forth. But here's the key thing. We have a build spec YAML file. And so when we call out to this, let's look at that. This is where the action's going when it's deploying the AWS Config Rules template. And so it's going through a couple YAML files and loops through those, and it runs Cloud Formation deploy. So it's deploying the stack onto the AWS account with these Cloud Formation templates. So as you can see, you can codify all the things. So you can codify your config rule itself. And so this is a snippet from that Cloud Formation template that you saw, in which you have a config rule, and you can define the properties associated with that. In this case, we're calling a managed config rule, so we're calling a kind of hard-coded reference source identifier for AWS, that S3 bucket public read. So you could have a Cloud Formation template that might have all your associated config rules all in one Cloud Formation template. And so this happens to be the first one, for example. So a few pro tips around config rules. One is configure AWS config related resources. You saw that using Cloud Formation. That gets committed into a source control repository like GitHub or code commit. Make a pipeline for all your resources, not just config rules, but all the associated resources for compliance, and of course the rest of your infrastructure as well. Extract your Lambda functions. So you can actually embed Lambda functions in a Cloud Formation template. But we find a best practice is really to extract those so that you can run linting, static analysis types of checks, testing against your functions themselves. And then configure, the last one is configuring SNS notifications. So, like I said, this was just a slice of a continuous compliance solution. There's also a number of other services that could ostensibly be a part of ensuring that your infrastructure is always in compliance. AWS Security Hub is an aggregation service dashboard tool, just was released, so expect more features coming out of that. In fact, there are integrations with config rules, but that would be Security Hub could be a part of a continuous compliance solution, especially in being able to view from an auditing perspective, for example, because that information can be collected in one place. So Amazon Macy, it looks for personally identifiable information, PII. So it can find things like usernames and password stored in data, credentials, things like that. Amazon Inspector runs inspections against your infrastructure and provides a report. You can actually include something like that in your deployment pipelines. Amazon Guard Duty uses machine learning, does intelligent threat detection, and so this could be a part of continuous compliant solution. And then you have AWS Trusted Advisor, which has been around for a while, but it's looking at lots of different aspects, including security and cost and things like that. But you can leverage its API and extend it for your own compliance checks as well. So there's a few config service limits to keep in mind. So this was just raised a few months ago, went from 50 to 150. It's a soft limit, so you can request a limit increase based on your usage. This is per region, per account. You can also have a number of aggregators. I didn't touch on that, but you can run this against multiple AWS accounts as well. So the solution costs, your charge for configuration items that are recorded per AWS region. Really where the costs are going to be is around config rules themselves. So the first 10 rules are $2 per active AWS rule per region per month. And then it starts to go down from there for the next 40 rules after that, and then 51 rules and more. It gets down to $1 per active AWS config rule per region per month. So there's a calculator when you add a config rule. There's a button you can click and you can estimate how much you might be spending for the month. AWS CodePipeline, you can do a lot of experimentation with this for pipelines, but after they've existed for more than 30 days and have at least one code change, then you're paying $1 per month. And then AWS Lambda, you can probably do a lot of this without incurring much cost with AWS Lambda, but if you exceed the free tier, then you get charged based on the number of requests to the functions that are running your AWS config rules. So you learn you don't need to rely on humans to follow outdated compliance documents or have separate compliance events where you're spending a lot of time and resources and to prepare for things like an audit. Instead, you can codify your team's policies and executable rules that get versioned and tested and part of a deployment pipeline. You can also use services such as AWS Config with config rules, CodePipeline, Lambda, and automate the whole process with Cloud Formation. And then this way you can ensure that your AWS accounts are always in compliance with your organization's policies so that you can deliver features to end users with speed and confidence. As I touched on, I showed one view on this, which is for a single AWS region. Instead, you could actually run this across multiple regions and across multiple accounts using an aggregator. You can also run compliance on code as a part of a deployment pipeline, run static analysis, look for checks like that. But it's really taking that continuous mindset, again, applying that to security and compliance. And so there's lots of things you can do with this. And so with these AWS services and automation, there's quite a bit that you can accomplish. And so you're always in a compliant state. So thanks a lot.